Okay, let's talk about how pressure varies with depth. Consider that we have a cylindrical container of some fluid over here with a base and top area of A. So these areas of A, and it's a straight wall, so it has the same area A on top and bottom, and it has a height of H. So that way that its volume is the area times the height. Is a cylindrical volume here. And the weight of this fluid would be the mass of the fluid times gravity there. So let's say that we want to find, what we're interested in finding is the pressure at the bottom down here. And we know that this pressure is going to be all the forces acting down on it. So this would be the sum of the forces in the y direction divided by the area. Pressure is force over area. And let's also say that we know there is some pressure acting down on it from the top up here as well. And we don't know exactly what this is. We'll just call it P naught, some starting pressure here. And since pressure is equal to force over area, this means that force is equal to pressure times area. So there's a force pushing down on the top, which is this, we'll call it F naught, is going to be P naught times A. So we have a force pushing down, which is the pressure pushing down times the area. So the sum of the forces in the y direction, taking positive y to be downwards, the sum of forces in the y direction would be P naught A plus mg. So then our pressure at the bottom would be equal to P naught A plus mg, all divided by area. Now the mass of this, if you remember back to the definition of density, density is mass. The density of the liquid is the mass of the liquid divided by the volume of the liquid. So this means that the mass of the liquid is going to be the density times the volume. So, and also remember that our volume was the area times the height. So the mass of this is the density times the area times the height. So if we take this and we replace it back in here, then we will get a pressure is equal to the starting pressure on the top, P naught A, plus density times area times height times gravity divided by this whole area. Now these areas are the same, both cases, so they would cancel out. We could factor them and divide out. And so the pressure at the bottom is equal to the starting pressure at the top plus density, I'm going to rearrange this, density times gravity times height. So this is pressure variation with depth. P is equal to P naught plus density times gravity times height. This is where a positive H is measured downwards. So this is positive H this way. Pressure increases as you go down. I mean, you can also measure, a negative H would be up this direction, and the pressure would decrease. That would just simply be negative. Note here that we define this for something that had straight walls, but this works just as well for, it's totally independent of the shape. If we have something that's like a cone, then the pressure in it, let's say that we have some liquid in here, then the pressure at this point down there would still be P is equal to, if this pressure, if let's say P naught is equal to 0, then pressure would just be equal to the density of the fluid times gravity times the height of the fluid, where this is taken to be a positive height. Same thing if we have another shape that looks something like this. With fluid all in here. Then the height that we are considering, if we want to know what the pressure is down here, the pressure is equal to P naught plus density times gravity times height, where this is the height here, and this is where we know P naught up here. It's